So this is a basic app I built. First thing it's going to do is it's going to create people. And these people are, it's just going to be a list of people. So it's John Fitzgerald Kennedy. You got Steve Fletch with Null, Awesome Possum. And so I'm going to return these people. And then what I'm going to do is a little bit of fake dependency injection here. This isn't really dependency injection. I'm sort of mocking out a system here. But I'm going to say I'm going to want a person SDK that can go hit an API or whatever the case is. I'm going to instantiate it with those people. And then I'm going to say for each of those people, just output their, I'm going to say for this person, we're going to check the middle name for whoever that person is. So all I'm going to do is I'm looping through these people, and then I'm going to say get, I'm going to hit this API for this ID. I'm going to say get that person's middle name. So for John, I'm going to give the ID, which will just be 1, and I'm going to output their middle name. Let's just go ahead and run it and see how that works first. All right, so boop, boop, boop. Okay, so what happened is that it tried to enumerate, it tried to loop through the people. It got John Fitzgerald. It says his middle name length is 10, and then it got to Steve and threw an exception. And I've got my what the heck in exception handler here, and it just outputs the message object reference not set to an instance object. So you can see back in my main program, I just have whenever it catches an exception, it's just going to throw that exception. So we all know what the problem is here. There's a null reference, object reference not set to an instance of an object. It's the bane of our existence as developers. So we're going to evolve into the next phase of this, which is, let's go to where the exception was thrown. We don't need to do the debugging to figure out where it's thrown. I know where it's thrown. So what happens when it hits this API, it says get middle name for person 1, which is John Fitzgerald, or JFK, which is John Fitzgerald Kennedy. So it's going to say get the middle name, and it's going to validate the middle name. And this is the purpose of this method is really just to output it to the screen and show us where our exception is. So we're saying middle name.length here, but for John that was fine because it's Fitzgerald and middle name was there. But for Steve Fletch, there was no middle name. It was null. So what I'm going to do is I'm going to say if middle name does not equal null, then output that. Let's just go ahead and say else. Otherwise, we'll go ahead and say something like output middle name len. No middle name to len, something like that. All right, cool. So our first level of evolving, we're just going to go ahead and do a null check. Not that big a deal. You probably have these all over your code. So we're going to go ahead and run it through. All right, look at that. No exceptions. So we've got John with a length of 10, Fitzgerald, Steve, no middle name to length. Okay, so we've got a Steve, but there's no middle name here. And then we've got Awesome Possum. Awesome Possum also didn't have a middle name, so it says no middle name for length. All right, cool. We did it. All right, this talk is over. No, I'm just kidding. So what I'm going to do is I'm going to now, I'm not just programming the blind. I've got my other screen going on here. All right, so for now I'm going to take it to the next level. So the first level is just let nulls propagate through your code, and we'll try to catch them everywhere we can. It's not the safest way to handle things. So one pattern that was made popular by Microsoft, not that I'm a Microsoft fanatic or anything, but one pattern is the Parse pattern. As you've probably seen, whenever you have a string with a number in it, and you say int.tryparse, and you pass it in. You can say int.parse, and it'll throw an exception if you pass in a word. But if you say int.tryparse, if it comes back null, then the point is that the tryparse will tell you there was a problem. The way it tells you there's a problem is that tryparse will return false, and that means, okay, well, let's use the tryparse's result, which was false, to say, okay, we don't want to use this, instead of relying on checking for null everywhere. So let's go ahead and do that. We're going to say try get middle name for person instead of get middle name for person. And we're also going to say, we're going to change this to the try-parse pattern, which is out string middle name. And we're going to change this to result in a bool. So what we're going to do is we're going to say, we'll pass in the person ID, we will return whether or not it was true or false, and the value, assuming it was true, will be inside of this out parameter. So let's go ahead and just make this work by going in here, doing this, Viola. I said Viola, okay. All right, so try to get middle name for person. We're going to, first of all, set, I originally did this as like let's walk through it, but let's go ahead and just change it like this. Okay, so what we're going to do is we're going to first set the middle name to null, and we're going to say person equals the repository, which is the database. We're going to get person by ID, and then here we're going to do the null checks. And what that's going to solve is that over here, out string middle name. There we go. I'm going to go ahead and pass the result into here too. Result, bool result. Okay, so what that's going to do is we're going to get back a true or false, whether or not they had a middle name. And now, instead of checking for null, we're going to say if result, then we're going to say this was the length of the middle name. Because we can trust that middle name is not null because the result was true. It could properly find a middle name and the result is true. So what we've done is say we're going to get the person from the repository by ID. So this is a full-on person entity. And then what we're going to do is we're going to say if the person equals null or the middle name is null or white space, then we're going to return false. This person, either the person doesn't exist or there's no middle name, whatever the case is. We couldn't get you a middle name for this ID. Otherwise, if we get past this, then we're going to say the middle name equals person.middle name, which we can trust the person is there and the middle name is there because of this condition. And then we're going to return true because true, we were able to get it. We can see that there's really no, this is foolproof. It's not foolproof, but it's closer to foolproof. And what we've bought ourselves is the ability to say we no longer have to worry about null for any of our consumers. So, all right, we've evolved one more level. Let's go ahead and take that to the next level, though, and say get person by ID. You know, that could very well have returned a null person. So we're still checking for nulls, and the problem is we control the whole stack here. So if we don't want to deal with nulls at the front boundary, the web API, or even anything beyond that, like the UI calling us or anything, why would we want to deal with nulls inside of our domain here? So person equals null. So what we're going to do is we're going to bam, 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 bam. So what we're going to do is we're going to change this, just like we did before, to a try get person by ID. We're going to call this success, like whether or not it was successful, and we're going to say out person entity person. So this is going to be the same thing, where it's going to try to get the person by the ID, and if so, it will output him here. Otherwise, it will, and it will always return either a true or false for the try pattern. But if it was false, then we can expect that there was no person, and if it was true, then that means that there will be a person inside here. So before I get too far into that, let me just go ahead and put the code in here. All right, so that's the full code. Now let me go ahead and jump into the this. All right, we've changed that pattern there, and perfect. All right, so now let's jump into the repository, and this is what the repository currently looks like. It's pretty simple. The code from the beginning is passing in those people that we instantiated. That's how the data gets it. There's not actually hitting a database. Like I said, I mocked out this system. But we save that list of people, and then whenever we call this repository, we just say get that person by ID from that list. So it's pretty simple. It just returns that list. But instead now what we're going to do, especially with this very simple pattern here, is we're going to change it to a try pattern that returns a bool, and we'll output this person. So what we're going to do is we're going to say person equals that, and we're just going to return true. So at the moment, we're assuming that this person definitely exists inside the database. So let's Let's go ahead and say run this. And one moment. Okay. All right. So we run it. It still works perfectly fine. It's like everything's perfectly fine with this. It says no middle name, no middle name. Everything's fine. But what if we take this to the next level? At the moment, the try pattern is, I mean, this is a little bit of a naive implementation for this one. This try pattern is saying, okay, we're going to handle whether or not this was successful. We're no longer dealing with nulls now in the domain here in the service. So what we're doing is we're able to deal with that try pattern, and so we've evolved here. But we haven't evolved here. This is pretty naive. There's a lot of things that could go wrong with this, especially being that it's single. It could not find it. It wouldn't find multiple because we're talking about an ID, which is going to be a unique field, but it could not find it. So it could be single or default. So let's go ahead and break ourselves. We're just going to break everything here. We're going to put this in here. So not only are we going to loop through the people that we have inside that list, we're also going to go ahead and make another call with this fake ID that definitely doesn't exist to look for a person. We'll just name them unknown for now. So we're going to loop through these people, and then we're also going to say, hey, give me ID 999, which doesn't really exist. So we're going to run this, and it's going to throw an exception. Not a null exception, though. It's going to throw the exception sequence contains no matching element, which is because in that .single LINQ statement, there is no 999. So let's go ahead and jump over here to the repo, and we're going to level ourselves up a little bit. So let me do this over here, do this. All right, so let's go ahead and wrap our stuff inside of a try-catch inside this repo. So we're just going to go ahead and do like this. Now what we're going to do is we're going to say person equals null, because whenever you have an out parameter, you have to make sure that no matter what, you're always setting that person. So person equals null. We're going to try to do this. Person equals single. And in case people are wondering why I'm using single instead of single.default or single or default, whenever I have something like this that is a LINQ statement, whether it's linked to entities or just linked to objects or whatever link we're talking about, and it's saying this is something I expect to definitely only be there once, definitely once. Because if someone says, hey, I have this ID 83612, they didn't just come up with that off the top of their head. If they're either probably trying to do a brute force or something like that. But I have this 83612 or whatever ID, and they say, get person by ID, here's the ID. It better be in the database. Like there should be a value, it should be a single value. And if there's not, I totally expect there to be an exception. Why was somebody trying to hit anyway? That's a whole different conversation, but that's why I'm doing single instead of single or default. The fix to this is not to do single or default. The fix is to say, for some reason you asked for an ID that isn't there, but if you're asking for it, it should definitely have been there anyway. So this is going to throw an exception. If it doesn't throw an exception, it'll propagate down to here. It will return true. But if it tries to hit this, it throws an exception. I don't care about catching at the moment. We'll get into that later. It'll end up returning false. So person will be null because this will end up failing. So it'll never assign back to person, and then it'll return false. So what's going to happen with this is, back over in the service, this will become false. It'll say if it equals false or whatever, it'll propagate false back. It'll just propagate it all the way up the chain. So now let's run it. Now that we have a try-catch in there, there we go. So John Fitzgerald with middle name Fitzgerald, a length of 10. Steve, no middle name. Awesome has no middle name. Unknown, that person who we just manually threw in there for unknown, it says that unknown doesn't have a middle name. That's not exactly true. That's that's misleading, because this is trying to say, oh yeah, ID number 999, they exist, or whatever the case is. We just couldn't find a middle name for them. This is a misleading statement. It doesn't say they exist, but you're going to assume they exist because it says, yeah, unknown. They don't have a middle name. So what we're going to do now is we're going to level up even further. Who's ready for this? Let me jump over here, jump over here. All right. Where should I start with this? Let's start in the repo. Okay, so we're going to backtrack a little bit, because this try pattern is pretty cool. Microsoft uses the try pattern in a couple different places. I've used it in some of my code back in the old days. I don't use it very often now, but it's something you can keep in your back pocket, and definitely feel free to use it every once in a while. But there's a lot better patterns out there. So what we're going to do is we're going to backtrack. We're going to say we're not going to use the try pattern. We're going to not output this person. We're just going to go ahead and say back to get person by ID. Sort of. I'm gonna evolve this a little bit more. What we're gonna do is we're gonna say, let's do var result equals new list of person entity. Okay. Oh shoot, we're gonna return a collection. So we're gonna do an IEnumerable of person entity. Now this is where we're gonna get a little bit confusing for a second, but bear with me while I work through this. Let me just say boop. What we're going to do, instead of returning a person entity, we're going to return a collection of person entity. It's a little bit misleading at first, and this is the way that monads came about. So we're going to say get person, singular, by ID, but we're returning a collection. It sort of doesn't make sense. So what we're going to do is we're going to have a result collection, and we're going to say try. We're going to try to add this to the result collection. If this ends up throwing an exception because the ID doesn't exist, it's going to bypass the catch, and it's just going to return result without having finished the add operation. So we'll return an empty collection. So essentially what we're doing here is we're saying we're either going to return an empty collection, but it will be a collection. It's not going to be null. So we're either going to return an empty collection, let me jump over here, or we're going to return a collection that has one item in it. And that's where mono comes from, the word for monadic. It's either going to be an empty collection or it will have one item in it. So just bear with me while I go through this. This is awesome. It's not the end result, but this is awesome. So this is the beginnings of something that is monadic. So I'm going to go ahead and take this and propagate it up a little bit. And do this. Oh, I want to go ahead and include that. All right, so our interface is updated, and then let's go ahead over to our service. So our service, let's go ahead and do the same thing. We're going to change this to something monadic. So we're going to say get middle name for person. We're going to return not just a string for the middle name, we're going to return an IEnumerable of string. I broke something. There we go. Okay, so we're going to return an IEnumerable string. And so the same thing, we're either going to end up returning 1, because there is a middle name, or 0, which means like we couldn't find it. Like there was no middle name, it couldn't be found. So let me jump over here, and we're going to say var middle, let's call it result, equals new list of string. And we're going to say var person equals, we'll say person enumerable for now. We'll just call it personal enumerable equals try get person by ID without that. Okay, so this is going to, like I said, going to be an IEnumerable. I know it's hard to see that on your screen, but it'll be an IEnumerable of person instead of a single person. And here we're going to say, especially because we know it's not going to be null, it's definitely going to be a list that has 0 or 1 results in it. We're going to say if person enumerable dot any. So if you don't know LINQ, LINQ is very helpful for functional type programming in C#. So we're going to say if there are any, which we know if there are any, that means there's 1. So if there are any, then what we're going to do is we're going to return person enumerable dot first, because first we know there's 1, so the first is going to be perfect, dot middle name, and it's going to look complicated, but we're going to simplify it here in a minute. New list of string with that middle name in it. So we'll say something like that, and we'll simplify it here in a second. I guess we don't really need this result right here. Otherwise, what we're going to do is we're going to return new list of string like that. I know how to write return, trust me. Okay, so we now have this. Let's go ahead and propagate this through our interface. And let's do that. Now let's propagate that up one more level to our web API. Get rid of the try pattern that we were using. Again, it's a perfectly good pattern. It's just not what we're going to be doing right now. Bam. So here we'll be now expecting an IEnumerable string, middle name, enumerable. Like I said, we're going to simplify this here in a second. Middle name. Yeah, we'll leave that here for a second. All right, so we're going to say the same thing. If middle name enumerable dot any. So if there is an item inside this collection, then we're going to say, we're going to output middle name length is middle name enumerable dot first dot length. So we know there's either 1 or 0. In this case, we're saying there is 1. So we're going to take that 1. We could even say single. That'd be perfectly fine. Dot length. Otherwise, like I said, if there aren't any, we're going to say there's no middle name to len to get the length off of. And then we're going to say here middle name dot single or default. And so this will be the either a middle name that's there or default, which is going to be null. But if it's null, we're going to say null. What we're going to return back here is, again, we have an enumerable here. So what we're going to return back here is dot single or default. Net result. Result dot single or default. Okay, so we've plumbed it through, but the plumbing through isn't the important part. I don't want to lose you guys, so I'm going to go back to the domain. I'm going to say we can simplify this even more. Not only can we simplify this even more, we've sort of lost our check on whether or not the middle name is null or empty. Right now we're just saying, assuming you sent me back, we're going to go ahead and assume that there's a middle name. So what we're going to do is we're going to say, I can just go ahead and copy this over. No, I'm not going to do that yet. Person enumerable. Person enumerable equals person enumerable dot where. So this is some LINQ stuff going on here. We know this is a collection. It has 1 or 0. So if it has 0, this where clause is just going to be skipped because there's nothing in there. So there's nothing in there to do a where clause against. So it's just going to remain 0. It'll just propagate through as 0. But if there is 1 in there, then this would be very helpful to say, and this is passing in the person, we're going to say where not string dot is null or white space x dot middle name. All right, so now we're back. We're back in business. So we've gotten back 1 or 0 people from the repo. We do a where clause, which will filter it. If it was 1, it'll filter it down to 0, or assuming that this passes through, it'll keep it as 1, because we only want the ones where the middle name is not null. So maybe it keeps it as 1. So if there is 1 still in there, then we're going to go ahead and return back that middle name. Otherwise, we end up returning back an empty list. But it's going to be simplified even more, which is really cool. So we're going to say, let's just delete all of this. That's a little bit scary. Let's delete all of this. So we've got this where clause, right? And we could say return. So if we return that collection, it will still, once again, it'll return either 0 collection or it'll return 1. And with that 1, it might even filter that down back to 0. But obviously a person is not a string. So what we're going to do here is we're going to say dot select middle name. So what we're doing here is we're saying of that person collection, we're going to filter them down, and then assuming there are any, if there's none at that, if it filtered it down to 0, then this select is going to be bypassed because there's nothing in the collection, so there's nothing to select. It's just going to return an empty enumerable. But if it did get here and there is the 1, then what it's going to do is it's going to select the middle name. So we've now converted that, and we can even simplify this more since we're only using this one time by putting this in here, and so getting rid of this. So we're saying get it by ID. We're saying where we only want ones if, this is like an if statement, if the middle name is not null or empty. And then also we're going to go ahead and select the middle name out of there. That's what we're going to transform this as. So let's go ahead and take this. We can actually simplify it even more. All right, so we've come a long way. We've taken this to the absolute extreme. we've gotten rid of all of that logic, and we've instead done a very functional way of programming using this monadic approach. This isn't the end here. This isn't the maybe monad, but this is a monadic approach saying there will either be 0 or 1 in here. And let's go ahead and say run. Okay, everything works perfectly. We're getting John Kennedy back with his middle name Fitzgerald. Mine says no middle name. Awesome Possum says no middle name. Unknown still says no middle name. So I've sort of fire hosed a little bit here. But let's go ahead and walk back through before I go to the next level. We're returning a collection instead of a single one. If there is a successful object, instead of using the try approach that Microsoft created, I don't know if they created it, but that they made popular. Instead of using the try approach, we're going to say, if it exists, then the collection will have 1 in it. If it doesn't exist, the collection won't have 1 in it. And that way we're not dealing with nulls. And not only does that give us the ability to not deal with nulls, what it also gives us the ability to do is a very dot notation functional based approach. So we're saying, okay, we're going to get back 0 or 1. With the 0 or 1, we're going to have this if condition, which is a where statement. We're going to pull out only things that match these conditions. And from that, we're going to map them. We're going to map them as just a certain property. I mean, we could transform them completely into a person model instead of an entity, or into a human or a child, or whatever the case is. We can transform them. But in this case, the way we're transforming it is we're just pulling out the middle name property. So we've now propagated that monadic IEnumerable up 1 level. So back inside of our web API, we can do things like checking if any. And now we're not checking for nulls. We're not saying if it's null or if it was successful. We're just saying if there are any first name. It sounds a little bit weird because any is very, first name is very singular. But if any first name, then go ahead and write that 1 first name, .length, etc. So we've propagated that up. But I could see why you'd be confused. I could see why anyone would be confused by this, because even when I see this type of thing, I'm like, I want a middle name, not a collection of middle names. So even when I know I'm working with this pattern, it's confusing in my head when I'm doing C# based stuff. So not only are we going to go into the maybe monad now, but we're going to solve for another problem. And that other problem is this. Unknown doesn't not have a middle name. Unknown doesn't exist at all. But at the moment, the way that we're doing things, we have no way to communicate that back. We're sending back an IEnumerable. With the try pattern, you're just sending back a bool. But with the try pattern, you can also send back an enum, not an enumerable, but an enum that says like was success or doesn't exist or through exception or something like that. It doesn't have to be a Boolean. But still, that's not quite enough. So we're not going to do a response object, but the cool thing is this monadic approach that I'm about to continue on to, called the maybe monad, is can act somewhat as a response object. So let's go ahead and level up our skills a little bit and move on over to that. Okay, so this is what we're going to do. Instead of using an IEnumerable of person entity, what we're going to do is manage NuGet packages. Let's go ahead and go to all. We're going to say gendev.utilities, just the utilities subsection of gendev.monad. There it is. Okay, so gendev.monad, we're going to install it. There's a lot of different monadic, maybe monads and things like that out there. I'm just going to go ahead and use the gendev, our Gen Studios monad. Instead of an IEnumerable of person entity, I'm going to change this to a maybe monad of type person entity. And it's pretty much a 1-for-1 trade. You can pretty much just do that. The difference is we don't need this. We can just say return that. So this is going to, even though this is a person entity that this is going to return, it'll automatically box it. There's an automatic boxing conversion for the maybe monad, so it automatically box it into an IEnumerable essentially. So it'll say, okay, you're returning a single thing here. We're going to box it into that maybe monad for you. And otherwise, what we're going to do is say return maybe.none. This is very simple to like enumerable.none or something like that. We're going to say maybe.none of type person entity. So we're saying there are none in this case. Actually, if you don't want to do the automatic boxing, you could say maybe.sum. So if it throws the exception here, it won't complete the sum functionality. It'll throw the exception and it'll come down here, it'll say none. But if it does complete this successfully, it will return sum, which means there was an object there. So it's just like adding one to the IEnumerable. This will add one to the IEnumerable. It will return sum, which is really just one. And this instead will return none. But beyond that, I said we're going to get into the try catch. What we can do here is say, and this is the same thing essentially. This is doing the same thing, but additionally, we can say use system. We can say return that maybe.none, but the people who were consuming this, if they get back that there was none, they can now see why there was none. They can see there's an exception. Or if it wasn't an exception, if you did this logically, you could say this is why it failed. Filed. This is why it failed. You can just put a message in there or something like that. In this case, we're going to go ahead and pass it back. I'm not saying don't handle your exceptions here. You should definitely be handling your exceptions here. Or maybe log things or whatever the case is that you're going to be doing. But you can now, instead of just returning null, be like, sorry, it didn't work. Or instead of, this is even worse, instead of throwing the exception, rethrowing it, or allowing it to be thrown, and allow something else in the future to catch it and control your logic based on exceptions being thrown, which is a horrible anti-pattern, what we're going to do is you're going to be able to say, I've handled it, because you should always handle your own exceptions inside your try-catch. I'm going to return to the caller, hey, this didn't work out. I couldn't help you. This is the reason why, in case you're interested. And just to be nice, I'm going to also add a fun, nice message for the person. So I'm going to give them the exception back, and I'm also going to say, and also here's a nice message that you can have. There's a way, you should not do this. Should be such a rare thing. There's a way to say, I want to catch exceptions and parse exceptions and be like, when x.message.contains lol, I only want to catch this exception type when parsing a message. But you should never rely on parsing messages. And I say that because even though I'm passing back a nice message, if you ever end up using any of these patterns or any patterns that work with exceptions, don't rely on parsing exceptions. There's super rare cases when you should, but never rely on. This is just for a human to read, essentially, not for the computer to read. Okay, let me jump over here. Okay, so we've obviously broken our interface. So instead of an IEnumerable, we're going to say we're returning a maybe monad, which is gendev.utilities.monad. And we're fixed. All right, so let's go to our service. We have to propagate this change up now. Our service is going to do the same thing. So we're going to say this is a maybe monad instead of an IEnumerable monad. Maybe monad with Gen Studios. Bam. Okay, so we're propagating this up. We're now saying repo.getPersonById, which is going to return that maybe monad. How best to jump into this without getting too crazy? Okay, so the functionality is going to change because we're not using an IEnumerable, so using a where clause is no longer going to work. Okay, so we can't use it as an IEnumerable, but what we can say is, I'm just going to comment this out for a second. I'm going to say dot match. So what you have in Monads, you have functions called match, map, and bind. I'm not going to go over all of them, but I'm going to say match. Match is definitely one that I'm going to do. And we're going to have two conditions here. So one condition is if it was successful, So like if the IEnumerable had something, then this is what I want to do. If it was not successful, so if the IEnumerable was empty, it didn't have one in it, then this is what I want to do. So what I'm going to do here is copy paste this in here, and then let's go ahead and put this down here. I think that should work perfectly fine. There we go. Oh, there we don't go. Did I keep an extra thing in here that does not need to be in here? Oh, here we go. Programming live. Oh, am I using 07? I'm using 07. No wonder. All right. I'm a crazy person. I was using the wrong match function. Okay, this is just because of our library. In our library, we have a match, and we have a match of type T because we have maybes that are of type T, and we have maybes that are just the base class. So, my bad. So what we're going to do is use a match of type T. And what that does, like I said, is in a match, you're going to say, if it was successful, do this. If it was not successful, then do this. So in this case, I've just sort of moved some of this down so that it doesn't clutter up in here. So we're just saying, we're going to pass the person in here. We're going to say, if string.isNull or white space, then return maybe.none. Like I said, that means that there was a failure with this message. Otherwise, return person.middlename. All right. So we're going to propagate this maybe. Instead of an IEnumerable, we're going to propagate this up through the service. And here, we're going to say, result. We're going to have to change this from IEnumerable to a maybe, obviously. Change this dot value. Okay, so we're going to get back that monad. Instead of an IEnumerable, it's a maybe. So we just need to change that from IEnumerable to maybe. And now instead of .any, we're gonna do, let's do the easy implementation first. So if you want to keep with your object-oriented if-then statement functionality, you could say if the monad, which is like the IEnumerable, if that has a value in it, then we can go ahead and use that value. So if it has a value, use that value. Otherwise, say there was no middle name or whatever the case is. And then here we're going to say, either way, write the middle name. But if there was no value, then say null. All right, so let's go ahead and run this before I finish cleaning this up a little bit. And, okay. Okay, so it's working out. It says John Fitzgerald, Steve with no middle name, Awesome with no middle name. It still says, checking the middle name for unknown, it still says there's no middle name, which isn't quite right. And that's because of the way we have this functionality. So instead of using this has value and things like that, what we're going to do is we're going to switch it up to say, Okay, we're going to switch it up to say, we're going to use that same match functionality. We're going to say the middle name, match T. We're going to say middle name, it's a maybe of string. If it had a value, then we're going to say middle name length is x.length. Otherwise, if it doesn't have a value, then what we're going to do is we're going to write the message. Why didn't it have a value? So we have the monad here, the maybe monad. We're going to write what that message was. Whatever the message was propagated from the deepest parts of the code, we're going to write that message here. So if it has a value, do this. If it doesn't have a value, then do this. And then either way, we're going to we're going to write either the middle name's value or the term null, something like that. All right, so we're going to run this one more time. And now we see John Fitzgerald, Steve, no middle name, Awesome, no middle name. For unknown, it says person doesn't exist with ID 999. Way more helpful. Once you propagate it all through your code, to have a message from the data layer that says why it couldn't find something. And all of this is possible without a whole bunch of if-then conditions, without null checks, without propagating null anywhere, and in a very functional monadic way. Dot notation, all kinds of awesome, really cool stuff. So that's all the way from the back end to the front end, using monadic structures, it's very similar to an IEnumerable, but also with a little bit of additional information. In this case, we have like, if it has a value, true or false, what the message was, if there was an exception there to be exception there. This is just a get. So if it's an exception state, if there's an exception, and then a whole bunch of functionality. There's not much to a maybe monad. You could probably write your own maybe monad and just using a basic class, a maybe class, a generic class that takes in a generic type and just says if it has a value or doesn't have a value. Implementing the ability to use matching functions is a little bit more, but yeah, that's the long and short of it. So go ahead and open up to some questions. I know there's a lot of fire hose going on with a lot of this information, walking you through a null check to instead doing a try, the try paradigm, like try parse, int.try parse and things like that. And instead evolving that into the IEnumerable monadic way of doing things. And then lastly, evolving that into a maybe monad. It's called a maybe monad. That maybe there's an object there, maybe there's not an object there. If there is, do this. If there's not, do this. So walking you all the way through that functionality, this becomes very, very helpful throughout your code base. If you start using it, you're going to get addicted. Just like the first time that you ever used an async task and you put a task on something, and then all of a sudden you're like, oh, the thing that calls this has to use a task. And then your whole code base, hopefully, your whole code base is using tasks all through it, and everything is using asynchronous tasks. And you sort of get used to it. You're like, oh, there's an async task there. Not that big a deal. Everything's an async task. Hopefully you get used to doing something like that. It's the same thing with a maybe monad. It's just something you get used to. This is an asynchronous task that returns a monadic string. You get used to reading this. It just looks perfectly natural to me. And match of T. Okay.